In this video, we will cover placing MEP connectors and adjusting connector properties. In this project, several components have been placed. When you select a component, you can see various options on the contextual ribbon in the Create Systems panel. These options are indicative of the connectors that have been placed on the component. The connectors control the system that the component can be added to. For example, when I select this duplex receptacle, you can see that there is a power option in the Create Systems panel. Let's take a closer look at connectors. I'll click Edit Family to open the family in the Family Editor. To begin, the tools to place connectors are located on the Create ribbon in the Connectors panel. This controls the discipline of the connector along with the systems that it can be added to. For example, I'll click Electrical Connector. When placing a connector, there are two placement options: Place on Face and Place on Work Plane. Typically, Place on Face will work and give you plenty of control over the connector. Place on Work Plane can also be used in certain situations. I'll click Modify to end the command, and then I'll select the connector that has already been placed. When I look at the system type, you can see that it is set to Power Unbalanced. And since it's a power type, I could have added it to a power system back in Revit. In other words, I could have added it to a circuit. When I expand this drop-down, you can see several other options. You can see Power Balanced and Power Unbalanced, along with several low voltage systems. For the Power Unbalanced connectors, you can also control the number of poles, and then you can control the power factor state, which can be lagging or leading. The load classification is also important, as that controls the load classification in Revit. And in this case, you can see that this parameter is grayed out and that there is an equal sign in the Associate Family Parameter button. That's because this parameter has been associated to a family parameter. And so it's always good to create family parameters and then associate parameters from the connectors to those family parameters. That will give you a little more control over your connectors when they're on a component that's been loaded into a project. You'll also see that the voltage and the apparent load phase 1 have associated parameters. In this case, the voltage of the connector is associated to the switch voltage parameter. I'll click OK to close that dialog, and then lastly you can see that you can control the power factor. I'll deselect this and then switch back to the project, and I'll select the receptacle again. When I click Edit Type, you can see the switch voltage parameter along with the load classification. So now I can control the voltage and the load classification of that connector for the family right here in the project. So just to summarize, it's good practice to create family parameters and then associate the connector parameters to those family parameters. Next, I'll select this security device and then click Edit Family in the contextual ribbon. When I select this connector, you can see that the system type is security. And there's really not many parameters for security connectors. I can specify a connector description, which will help when I'm adding this component to a system, but other than that, there's really not much there. Same thing for the other low voltage systems here. There's really not many parameters that you have to deal with. But if I were to select Power Balanced or Power Unbalanced, then you could see there are several other parameters. I'll close this and not make any changes. And then lastly, let's select a cable tray fitting and then click Edit Family. And when I look at cable tray or conduit fittings, you'll notice that the connectors will be a little bit different. First off, they are cable tray or conduit connectors, and then there are different options that they have as far as different parameters. Mainly the size of the connector is important when you're dealing with conduit and cable tray, but once again you will want to associate those to parameters that control the geometry of the fitting. So in this case we have a tray height parameter that's being used to control the height of our cable tray connector. If you notice these dashed lines in the drawing area, they simply indicate that the connectors have been linked. So you can see here there's a remove link option in the contextual ribbon, as well as a link connectors option, and when you see this dashed line it means that they've been linked together. So electrical connectors, those are going to control the circuits that they can be added to, and then cable tray and conduit, that's going to control your cable tray and conduit connections in the project, and the important thing there is really the size. In this video, we will cover differentiating between system and component families and editing system and component families. In this project, several elements have been placed. It's important that you understand whether an element is a system family or a component family. Another way to refer to component families is loadable families. They are defined in an external family file with a .rfa file extension and then loaded into the project. System families are defined within the Revit project. On the MEP side, system families are typically conduit and cable trays and duct and piping. There are several more, but those are the main ones that you need to be aware of. When I select a cable tray, I can then click Edit Type to open the Type Properties dialog. I can then use any of these parameters in the Type Properties dialog to control this family type. I can click Duplicate and create a new type as needed. I'll click Cancel to close the dialog and then select a cable tray fitting. When I select the fitting, you can then see Edit Family on the contextual ribbon. When you see Edit Family, you know that that element belongs to a loadable family, because you can then edit it in the Family Editor. When I select some of the other components, you can see that Edit Family is available. These are all loadable family components. I'll select a light fixture and then expand the type selector. You can see several types, specifically 6 types that are available. And if I click Edit Type, I can adjust any of the type parameters to control this family type. I'll click Cancel, and then I'll click Edit Family to open this lighting fixture family in the Family Editor. As you can see, this is a .rfa file, and the tools that are available are completely different than those in the project. There are tools for creating geometry and adding connectors, and also adding parameters that will define this family. When I click Family Types, I can then expand the Type Name dropdown and see those same 6 family types that were available in the project. I'll click Cancel and then switch back to the project. When I select the lighting fixture and click Edit Type, I can also create new types right here in the project. For example, I'll click Duplicate, and then we'll name this type 2x2-120 and click OK. Then I will adjust the length to 2 feet so that it's 2 feet by 2 feet, and then I'll click OK. When I do, the lighting fixture updates, and when I expand the type selector, you can see the new type that I created. I'll select 2x4-277 and then click Edit Type and click Duplicate again. We will create a 2x2 type That's 277 volt as well. And then I'll click OK. Now when I expand the type selector, I have 8 types. I will now switch back to the family file and go to the family types dialog. And when I expand the type name dropdown, you can see that there are still just the 6 types. And so this can be somewhat confusing, and it's something that needs to be managed properly when you're working with loadable families. When you create a family and then load it into the project, you essentially have 2 versions. Because while it's a loadable family and defined in an external family file, when you load it into the project, it is then saved as part of the project. And so you can edit that family in the project just like we did, and it doesn't affect the RFA family file. And so that's something important that you need to be aware of. I'll click cancel, and then I will close this family file, and then I'll select the one in the project, the one that has 8 types, and then click edit family. Now I'll click family types and expand the type name dropdown, and now you can see all 8 family types. And so once again, you can see that this is something that needs to be managed properly. And as far as when you edit a family in a project, are you also then opening it and saving it in an external family file, or are you just going to manage it all within a project? And so that's something that you need to be aware of and have a plan for. I'll select the 2x2-120 type that we modified, and you can see several parameters here, and I can update any of these parameters as needed. Now I will change the default elevation to 3 feet, and then I will also change the tilt angle. Let's change this to -80 degrees, and then I'll click OK. And now, since I've made changes, I want to load that back into the project, and I'll click Load into Project, and when I do, I get a Family Already Exists dialog. There are 2 options here. I can overwrite the existing version, or I can overwrite the existing version and its parameter values. So if I just click Overwrite the existing version, I would override any geometry changes or if I added any parameters, but the parameters that I updated would not change. In order to do that, I would need to select the second option, overwrite the existing version and its parameter values. However, you have to be careful with this because, as you can see here, it's going to overwrite parameter values. And so I'll select that option, and then we can take a look. So I select this and click Edit Type. You can see that the default elevation is still 4 feet, and actually that's because I have the wrong type selected here. Okay, if I switch to the 2x2-120 type, you can see that the default elevation is now 3 feet, and my tilt angle is -80 degrees. And that happened because I overrode the family and the parameter values. And so you want to be careful when you're doing that, because if you had customized a lot of these parameters in the project, and then you would override them here in your type properties dialog. So you have to be aware of what's going on there, and you have to have a plan for managing these family types. So just to summarize, system families are controlled right here in the Revit project, whereas loadable families, they can also be controlled in the project, but they are actually defined in an external family file with a .rfa file extension. In this video, we will cover recognizing family creation best practices and creating parametric geometry and connectors. To create a new family, click the File tab and then select New Family. In the New Family Select Template File dialog, you can select the template you want to use to begin your family. For this example, select Electrical Equipment and then click Open. To create a parametric family, there are some best practices you should follow. This includes starting the family by creating the framework with reference planes, and then adding dimensions to control the reference planes. After that, you can label the dimensions and then create geometry and constrain it to the reference planes. This will be the start of a parametric family. For this example, we'll begin by creating a box that we can then use as a transformer. We'll begin by creating the framework with reference planes. On the Create ribbon, in the Datum panel, click Reference Plane. I'll click to place 2 points to define a left reference plane. Then I'll create a right reference plane. And then we'll create a front and a back reference plane. Then I'll click Modify. When you select a reference plane, you can give it a name. I'll name this one Left, and then you can control the isReference value. And this determines the priority of dimensioning it in a project. I'll select this one to Left. If this was a weak reference, then it would have a lower priority in the project, and if it was not a reference, then you wouldn't be able to dimension to it. In other words, you wouldn't be able to snap a dimension to it in the project. So I'll select Left, and then for this one I'll select Right. And also when you name it, you will get a tooltip that'll show its name in the project when you're dimensioning to it. And so that's a good reason to name it. It also just helps to keep things organized so that other people that may be looking at your family will know what you're trying to do here. Alright, so we have front, back, left, right, and then we also have center left, right, and center front back reference planes that are created and pinned by default. Also note that Defines Origin is selected for the 2 that are created by default, and the intersection of the reference planes that are set to Defines Origin will be the insertion point for the family. So if you wanted to change that to a corner, you could select Defines Origin for one of the other reference planes. Next, I'll switch to the front elevation view and create one more reference plane. There's that extension line. Now, the next thing we'll do is add dimensions. So on the Annotate ribbon, in the Dimension panel, I'll click Aligned Dimension, and then I'm going to place a string here between all of these, and then click the EQ to create an equality constraint, and then I'll create an overall dimension. And so what this will do is it'll keep the left and right and then front and back reference planes, it'll keep those at an equidistance away from the center so that we can keep our spacing nice and neat. And then we'll create one more dimension and then click Modify. Next, we want to create parameters so that we can label the dimensions with the parameters. And what we can do is we can go to the Family Types dialog, and the Family Types button is available on the Modify ribbon and on the Create ribbon. And in this dialog, we can create types, and then we can also add parameters. You can see that there are several parameters that are created by default, and these are added to the template that we used, and so that's why they appear here. It's because we started using the electrical equipment template. I'll click New Parameter, and then we will create parameters for the length, the width, and the height. And one more for the height. And I'll click OK. And we'll use a value of 5 feet to get us going. And I'll click OK. Now, when I select a dimension, you can see that there is a Label Dimension panel on the contextual ribbon with the label drop-down. Since I have a length dimension selected, any of the applicable dimensions that I can use to drive this dimension will be available. So in this case, I'll select length, And for the other one, I'll select width. And then in the front view, I'll select the dimension and label it with the height parameter. Now at this point, we have parameters that are driving our reference planes, and so we can now create geometry and then constrain it to the reference planes. On the Create ribbon in the Forms panel, click Extrusion, and then in the Draw Gallery, select Rectangle, and we'll snap to 2 corners of our reference planes. And then after the sketch line is placed, you'll notice the padlock icons. I can click those padlocks to constrain the sketch line to the reference plane. And this takes care of our 2D sketch, and I'll click Finish Edit Mode, and there's still a height parameter that we need to account for. So with the extrusion selected, I'll switch to the front elevation view, and there are controls that I can use to drag the top and bottom. So I'll drag the top up to our top reference plane, and then when I do, we see another padlock icon, so I'll lock it. And our bottom, the bottom of the extrusion is where we want it to, but it's not constrained, and so I'm going to click the control, drag it up and then back down, and then lock it. And then I'll deselect the extrusion. If I switch to the 3D view, I can orbit around and you can see our parametric cube that we have right now. And the next thing we want to do is add an electrical connector. So on the Create ribbon in the Connectors panel, I'll click Electrical Connector. And then in the Placement panel, I'll make sure Place on Face is selected. And then I will select a side face. If the one you want is not highlighting, you can press Tab and then click to select it. And then I'll click Modify to end the command. We'll leave that there on the side, and we'll leave it centered in the face. And then we'll open the Family Types dialog one more time, and to wrap up, we are going to do what's called flexing our family, which is adjusting the parameter values and making sure that everything adjusts accordingly, making sure that our geometry is constrained appropriately, and it appears everything's working like we want it to. And so we now have the start of an electrical equipment family. And so just to summarize, best practices are to create your reference planes to define the framework of the family, and then add dimensions to control those reference planes, and then label the dimensions with parameters, and then constrain the geometry to the reference planes. In this video, we will cover defining the light source definition and checking light source placement. When working with lighting fixture families, the light source is an important component to pay attention to. In this project, select one of the 2x4 lighting fixtures and then click Edit Family. When the lighting fixture family opens, you can see that this is a face-based family, and the light source is actually upside down. This is the way that it needs to be, because right now we're viewing the face of the extrusion, and when placed in a project, the lighting fixture will be placed on the face of the ceiling, and so that's why the lighting fixture is upside down in this view. The yellow component is the light source, and you can select it in the view as long as it's enabled. If this was not enabled, you can check Light Source in the Properties palette with nothing selected. Select the light source, and then you can see the parameters in the Properties palette, and there's also a Light Source Definition tool in the Contextual ribbon. When you click Light Source Definition, it opens the Light Source Definition dialog. There are two controls here: Emit from Shape and Light Distribution. For Emit from Shape, you can select Point, Line, Rectangle, or Circle. In this case, we're working with a 2x4 lighting fixture, so Rectangle is selected. Under Light Distribution, you can select Spherical, Hemispherical, Spot, or photometric web. Be aware that if you want to use an IES file to define the light distribution, you need to select photometric web for that parameter to be available. For this lighting fixture family, photometric web is selected. So I'll click OK, and then looking at the parameters in the Properties palette, you can see that the photometric web file is one of the parameters that's available. All of the parameters are actually associated to family parameters. When I click Associate Family Parameter next to Photometric Web File, you can see that it's associated to the Photometric Web File family parameter. I'll click OK to close the dialog and then deselect the light source. Then I'll click Family Types. When I scroll down to the Photometrics properties and then click in the Photometric Web File Value field, there's a More button. You can click this button and then navigate to the location where the IES file is saved, select it, and then click Open. There are also several other parameters that you can control, such as the tilt angle, light loss factor, initial intensity, and so on. I'll click OK to close the dialog, and then in the project browser I'll expand Views, expand Elevations, and then I'll open the front elevation view. Here you can see the extrusion, which defines the face for the face-based family, and the light source. Now, a common mistake when placing light sources is that they are placed inside the geometry of the lighting fixture, or they're placed inside of something. And that will be an issue when the component is loaded into the project. And so the light source needs to be on the exterior face of the fixture. And so in this case, the lighting fixture is going to be placed in the ceiling, and then the light source is on the exterior. So we're in good shape here. If the light source was placed inside, then we could have some issues inside the project. Lastly, I'll switch back to the project, and then I'll select the downlight spotlight and click Edit Family. And when this family opens, you can once again see the light source, and I'll select it, and then I'll click Edit next to Light Source Definition. Now, this light source is a point because it's a spotlight, and then the light distribution is set to photometric web. And we have a photometric web file that's being used to control the light distribution here. So, in summary, the main thing you need to pay attention to with the light source definition is emit from shape and light distribution, and to use an IES file, you need to have photometric web selected. In this video, we will cover determining the family category and determining the part type. When you are creating families, it's critical that they are assigned to the correct category and part type. The category controls some of the default parameters that will be available, and also controls how the visibility and graphic display will be handled in the project. Let's take a look at how this works. I'll select one of the transformers in the project, and in the Properties palette you can see that this is an electrical equipment component. I'll click Edit Family to open the component in the Family Editor. When creating a family, you typically start by choosing the template that you want to use to create the family. The category will be specified by default based on that template, but sometimes you may need to adjust this. On the Create ribbon, in the Properties panel, click Family Category and Parameters. This opens the Family Category and Parameters dialog. In the Family Category section, you can see that electrical equipment is selected. Back in the project, this was what the transformer was listed as, was electrical equipment. But if needed, you could adjust that here. Also, in the Family Parameters section, you can see a part type parameter. This is an additional level of classification for a family. When you expand the drop-down, you can see the options. These options will be different depending on what the category is. So for electrical equipment, we have equipment switch, other panel, panel board, switchboard, and transformer. So this will affect how the electrical equipment behaves in the project. In this case, it's a transformer. I'll click Cancel to close the dialog and then switch back to the project. Next, I'll select a cable tray fitting and then click Edit Family. You can also control the part type in the Properties palette. This cable tray fitting is a channel elbow. And when I expand the drop-down, you can see several other options. Once again, the part type will add an additional level of classification to the family, but it also controls how it behaves in the family. So the part type of channel elbow allows it to be a channel elbow in the family. And so the family is a channel horizontal bend, and then it can be selected for a channel elbow for a cable tray type, and then it can be swapped out for other channel elbows in the project. I'll switch back to the project one more time, and I'll type VV to open the Visibility Graphic Overrides dialog, and you can see here that on the Model Categories tab, the visibility and graphic display settings are by category. So once again, it's critical that the category and part type be specified correctly when you first create a family. That way it will behave like you want it to in the project. In this video, we will cover differentiating between hosted and non-hosted families and recognizing family hosting types. Using hosted versus non-hosted components is a classic Revit debate. Some people have strong convictions on one side or the other. Which method you use should depend on your workflows and what's going to work best for your projects. To begin, let's go through the process of creating a new family. Click the File tab and then select New Family. In the New Family, select Template File dialog. You can select the template you want to use to start your family. I'll scroll down to the generic model templates, and you can see that there are several hosting options. There's generic model ceiling-based, face-based, floor-based, line-based, pattern-based, roof-based, wall-based, and so on. Not every category has all of these options. For example, for lighting fixture, there's ceiling-based and wall-based, but you can select one of the generic model templates, such as generic model face-based, and then change the category of that family. Now, it's important to note that when working with MEP elements, face-based is typically the way to go. And the reason why is because if you select the lighting fixture ceiling-based or another ceiling-based template, then the ceiling must be in the host model. In other words, you can't place a ceiling-based lighting fixture in the ceiling of a linked architectural model. And so once again, most of these require that the host component be in the host model, whereas face-based will allow you to place it on a surface in the linked model. And so that's typically the way we want to go with MEP components. I'll select Cancel. We won't create a new family right now. And I'll zoom into the electrical room. When I select a panel board, you can see a placement panel on the contextual ribbon. And you can see that face is selected. And so this is typically indicative of a face-based family. There's also a Pick New tool, which is Pick New Work Plane. And so right now, this panel board is hosted to this wall in the architectural model. But you could select Pick New, and then you could select another wall in the architectural model, or another face if you desired. Once again, that is typically indicative of a face-based family. You can also click Edit Family to open the family, and then in this case we see an extrusion along with the panel board. And so that extrusion indicates that this is a face-based family. I'll create a new family real quick just to show the differences. If I select lighting fixture ceiling based and then click open, we can see a ceiling component in the family. And so the point I'm trying to make here is that when you're working with some type of hosted component, you're going to see a host element in the family, and it should be labeled according to what the host is. So in a face-based family, we have an extrusion, and that indicates that we can place this panel board on a face. And when we're placing a face-based family, we can choose to place on a vertical face or a face of any orientation. Okay, now once again, that's how you can tell if a component is a hosted component and specifically what that hosting type is. And now to see something that can happen with hosted components is if they become unhosted or their host element is no longer there, then they become an orphaned element. And so we can see that by removing the link. And so if we switch to the Manage ribbon, and then in the Manage Project panel, click Manage Links, and then we'll select the linked architectural model and select Remove, and then click OK. And we will receive a warning, several warnings stating that a hosting element no longer exists. And so we'll click OK, and then click OK to close the Manage Links dialog. And now if I select that panel board, you can see an icon next to it that indicates that it is an orphaned component. And to see all of those, I can switch to the Collaborate ribbon, and then in the Coordinate panel, click Reconcile Hosting. And this opens the Reconcile Hosting panel, and you can now see all of the orphaned elements, and they are divided up by category. And so in this case I have electrical equipment and electrical fixtures that are orphaned. And as you can see here, there's several components, duplexes, electrical equipment, several things that have become orphaned. And so that's one of the reasons some people like to stick with non-hosted components, is so they don't have to worry about that component becoming orphaned. But some people like to have a host that they can host it to so that it remains connected. And so in the case of a wall, say we have electrical fixtures that are hosted to a wall, and if that wall were to move in a certain direction, then the fixture would remain hosted to it. Now we do have some issues with lighting fixtures and ceilings, and so once again they can be hosted to a ceiling in an architectural model, but they can't be hosted to the ceiling grid. So in other words, if the ceiling moves up or down, the lighting fixture would remain hosted to it, but if the ceiling grids were to move, the lighting fixture would not move with it in the linked architectural model. So once again, hosted versus non-hosted components, a classic Revit debate, but you should use the method that works best for you and your projects. In this video, we will cover controlling family geometry visibility and controlling family geometry graphic display. When you are creating families, you can control how they appear in various views of your project. For example, in this Level 1 view, the detail level is currently set to medium. When you change this to fine, you will notice that some of the components update. And when you change the detail level to coarse, you can see additional changes. For example, the duplex receptacle appears in symbolic form at the coarse and medium levels of detail, but at the fine level of detail, you can see the actual geometry. I'll change the detail level back to medium and then select the duplex receptacle. Click Edit Family in the contextual ribbon to open the family in the Family Editor. When the family opens, you can see an extrusion and the receptacle geometry appears on the extrusion. So first off, this is a face-based family, and we can tell that because of the extrusion. And then when we open the reference level floor plan view and zoom in, we can see the duplex symbol. Now, this can be a little tricky because right now in the floor plan view we're looking at the face of the extrusion. But let's talk through some of this. To begin, select one of the geometric forms of the extrusion and then pay attention to the Visibility Settings tool on the contextual ribbon. When you click Visibility Settings, this opens the Family Element Visibility Settings dialog. For geometry, you can control the view-specific display as well as the detail levels that the geometry will appear in. So, right now, this geometric form will appear in both plan and reflected ceiling plan views and left and right views, but will not appear in front or back views. And it will also appear at each of the 3 detail levels. And I'll click OK, and then next I'll select the symbol and click Visibility Settings again. For the symbol, you can see that there's a symbolic element visibility control, but as it says there, symbolic elements are view direction specific, so they only show in views that are parallel to the creation view. And then this symbol is set to show at just the coarse and medium levels of detail. It will not appear at the fine level of detail which we saw. But what can be a little bit confusing about some components that use symbols is that right now we're in the reference level floor plan view and we see the symbol and the geometry also appears here, but this is actually a front and back view for the actual geometry itself. And so we can tell that because we're viewing the face of the extrusion, which back in our project, that is the wall. So it's placed on the wall face, and so here it's like we're viewing the wall face, but we're in the reference level view, and so that's where the symbol is placed. And so that's why when we take a look at the visibility settings, it's set to not display in front and back views, which is technically our level 1 floor plan view in the project. And so that can be a little bit confusing, but that's how it works when you're dealing with face-based families. So once again, the symbol appears at the coarse and medium levels of detail, and then if I switch to the front elevation view and zoom in, you can see what appears in the plan view at the fine level of detail. And we actually have symbolic lines here, and once again you can see that they appear at fine and not at coarse and medium. And so that's what we saw in the project. And so once again, right now I'm in the front elevation view, which corresponds to our floor plan view in the project. And so it may take a little bit of experimenting and taking a closer look at these families so that you can get a better feel for how that works. Next, I'm going to switch back to the project, and then I'm going to select the transformer and click Edit Family. Now we're going to look at how we can create a clearance zone and have it appear differently than the transformer itself. And we can do that by creating a subcategory for the family geometry. So I'll create a clearance zone on the side where we have the electrical connection, and I will start by creating a reference plane. And then I will create an extrusion. So I'm going to skip adding the dimension and a parameter for this example. And we'll go ahead and lock these. And then I'll click Finish Edit Mode. And then open the front elevation view. And we'll match the height of the transformer. and then I'll open a 3D view. So now we have a clearance zone, but it's going to appear exactly like the transformer, which is not what we want to, that's not the functionality we want to have. And so what we want is it to appear differently. In this case, we'll have it appear red with a dashed line. And so on the Manage ribbon, in the Settings panel, click Object Styles, and here we can create a new subcategory. In the Modify Subcategories area, I'll click New, and I'll name this Clearance Zone, and then click OK. And now we can control the line weight, line color, line pattern, and material. So I'll change the color to red, and we'll select a dashed line. And if we wanted to continue on, we could create a material that is transparent, and that would help us as well. I'll click OK, and then I will select the form, and you can see that there is a subcategory parameter, and I will assign it the clearance zone subcategory. And when I do, you can see that that clearance zone geometry updates. One more thing I'll point out is that there is also a visible parameter, and we can associate that to a family parameter. So I'll click Family Types and create a new parameter called Clearance Zone Visibility, or I'll call it Clearance Zone Visible, and we'll make it an instance parameter. And the type of parameter needs to be yes, no, and I'll have it appear under Visibility, and then I'll click OK, and we'll leave it set to be visible by default, and I'll click OK. And then when I select the clearance zone geometry, I can click Associate Family Parameter next to Visible, and we'll select Clearance Zone Visible and click OK. And now I'll load it back into the project, and we'll take a look at what happens. I'll overwrite the existing version, and now we have our clearance zone, and so it doesn't appear dashed because it's smaller, but if I were to change the scale, maybe I went in the wrong direction. There we go. Now you can see the dashed line, and if I select the transformer and scroll down to the visibility section, I can control the visibility of that as well. So once again, you can control whether components are visible, and then you can control their graphic display as well. In this video, we will cover differentiating between annotation and model families and controlling labels in tag families. In this project, several tags have been added. When adding tags, it's important to keep a few things in mind. First, tags are view-specific elements, so they will only appear in the view in which they are placed. Additionally, tag families are made up of labels, and the labels control which parameters the tags report. So you need to know which parameters are being reported in the tag. For this example, I'll select a lighting fixture tag, and then on the contextual ribbon, click Edit Family. When the tag opens in the Family Editor, you can see that on the Create ribbon, there are tools to add lines, symbols, filled regions, labels, text, and several other options. This is completely different than the tools that are available when you create model families. Once again, tags are view-specific elements, and they do not contain model geometry. The main thing you need to pay attention to in tag families are the labels. For this example, there's just one label. Before we take a look at that, I'm going to select the lines and delete them. And then select the label and click Edit Label in the contextual ribbon. In the Edit Label dialog, you can see the parameters that are added to the label. In this case, we have the circuit number. If you want to add additional parameters, you can select them in the list of category parameters. If the parameter you want to use is not available, you can click Add Parameter, and then select the shared parameter to add. Be aware that only shared parameters can be added to tag labels. I'll click Cancel, and then I'll select the type mark and add it to the label. When you have multiple parameters, you can control the order in the list. So I'll add the type mark and then the circuit number in the second spot. For each parameter, you can add a prefix or a suffix, and you can also control the sample value. For sake of example, I'm going to enter in a sample value and we'll call it LP10, and I'm going to leave a space there just for sake of example of showing how some of these options work. You can also add a break line in between the parameters, and if you do that, then regardless of the size of the label box, there will be a break between the parameters. You can also choose to wrap between parameters only, and when this option is selected, each parameter will have an individual line. So in other words, the size of the text box will not affect the wrapping. It will only wrap between parameters. So I'll click OK and we can see how this works. So you can see here that with wrap between parameters only deselected, if the label box is smaller than the length of the value, then it will wrap. And notice that there's not a dash. If it was all a single value, then it wouldn't wrap. When I choose to wrap between parameters only, which I can do so in the Properties palette, then it will no longer wrap because it's only going to wrap between the parameters. Also, in the Properties palette, you can control the horizontal and the vertical alignment, and then you can choose whether or not to keep the tag readable. If Keep Readable is selected, then if the tag rotates beyond 45 degrees, it will flip. There's also a visible parameter, and this is handy if you have multiple labels. You can then create family parameters and create types and have different labels visible for different types. When you click Edit Type, you can then adjust the graphics and text parameters in the Type Properties dialog. For the graphics, you can control the color and the line weight, and then you can control the background. And so when this is set to opaque, then it will cover any of the components that it's on top of. In this case, it's set to transparent, and so you'll be able to see those components behind the tag. I'm going to select Show Border for this example, and then you can also control the leader and border offset. And then under text, you can control the text style that is used so that your tags can meet your graphic standards. I'll click OK and then deselect the tag, and you can now see the border that appears around it. And if you want it to be a little bit closer, you can adjust the leader border offset so that the border is a little bit closer to the text. The last parameter here that we'll touch on is Rotate with Component, and that is a parameter for the overall tag. And when this is selected, then the tag would rotate along with the component. And so this is particularly useful when you're working with conduit and cable trays. And if you want that tag to be on top of the conduit or cable tray, you could select it to rotate, and then it would rotate along with it. If not, then you can choose for it to be vertical or horizontal in the project. I'm going to click Load into Project and then overwrite the existing version. And now we can see our updated tag, and we obviously need to make some adjustments here as it's appearing over the light fixtures. But as you can see, we can use those options to customize our tags and control which parameters are being reported, and then also control how they appear. In this video, we will cover adding generic annotations to model families and using labels in generic annotations. When creating families, you can choose for the actual geometry to appear, or you can choose for a symbol to appear. If you want a symbol to appear, there are multiple ways that you can handle this. Let's take a look at some examples. In this Level 1 floor plan view, you can see several components that are using a symbolic representation. When you change the scale of the view, you will notice that some of these components update in size. I'll change the scale back to 1/8 of an inch equals a foot, and then we'll take a look at why some of them changed in size and some didn't. Select a lighting fixture and then click Edit Family. In the Family Editor, open the reference level floor plan view and then zoom into the lighting fixture. This lighting fixture has symbolic lines that are constrained to the reference planes and so that they will match the size of the lighting fixture. And so this is a great way to show a lighting fixture symbol whereas the symbol will match the size of the lighting fixture. And that is done with symbolic lines. On the Annotate ribbon in the Detail panel, you can find the Symbolic Line tool, and you can sketch lines and constrain them to reference planes. When you select a symbolic line, you can click Visibility Settings to open the Family Element Visibility Settings dialog. Symbolic lines will appear in views that are parallel to the creation view, and then you can choose the detail level that they will be visible at. Click Cancel to close the dialog. On the Create ribbon, you will notice that there is a Model Line tool. Model lines and symbolic lines are completely different. While symbolic lines will display in views that are parallel to the creation view, model lines will appear in any view, and you can control the visibility just like you would a model element. So if you wanted the symbol to appear in say a 3D view, then you could use a model line. Let's switch back to the project and then select a duplex receptacle and click Edit Family. Once again, open the reference level floor plan view. In this family, when you select the symbol, you can see that it was created as a generic annotation. This is actually a nested generic annotation family. And as you saw in the project, the size of this generic annotation changed when the scale of the view changed. While model elements will always be the actual size, generic annotations will scale along with the view, similar to text and tags. And so if you need a component symbol to scale, then you want to create it as a generic annotation. If you wanted a nested family and you didn't want it to scale, you could create it as a detail item. But in this case, we have a generic annotation family, and we can click Edit Family to open the generic annotation family. In the Family Editor, you can see tools that are similar to creating a tag family. The generic annotation was created with lines, and on the Create ribbon there is a Line tool. These lines behave similar to symbolic lines. There is also a label, and when you select the label, you can click Edit Label in the Contextual ribbon to see the parameter that is added to the label. In this case, the parameter is called Label. I'll click Cancel, and we'll close the Edit Label dialog, and then we'll switch back to the duplex receptacle family. When I select the generic annotation, you can see that the label parameter is associated to a parameter in the duplex receptacle family. And if you click the button to open the Associate Family Parameter dialog, you can see that it's associated to a label parameter in the duplex receptacle family. So what this allows you to do is set a label parameter in the duplex receptacle family and have the label in the generic annotation family populate. I'll switch back to the project. So as you can see, there are multiple ways to handle symbols in a family. You can either use symbolic lines or model lines, or you can use generic annotations or detail items. Generic annotations will scale with the view, and you can create labels and associate them to family parameters. In this video, we will cover recognizing the available parameter types and working with the available parameter types. When working in Revit, information is key. In order to add information to a building model, it needs to be added to a parameter. There are 4 different types of parameters that you can create and use in Revit: project parameters, family parameters, shared parameters, and global parameters. Let's take a look at each one. Project parameters are specific to a project file. Hence, they're called project parameters. When you create a project parameter, you can assign it to categories of elements. And then the project parameter can be used in schedules, but it cannot be used in tags. Project parameters are great when you need to add a single parameter to both system families and loadable families. Or if you have several loadable families in a project and you need to add a parameter to them without opening the families, then you can add a project parameter and it will be added to all of those components in the project. For example, if you have several lighting fixture families in a project and you need to have a specific parameter in each of those lighting fixtures, then you can add a project parameter. So this is a quick way to add that parameter to all of the lighting fixtures without having to open up each family and adding it as a family parameter. The only downside is that if you need to use that same lighting fixture family in another project, then it won't be available. So you'll either have to create the project parameter in the new project or just add that parameter as a family parameter to each lighting fixture. But once again, project parameters are a great way to quickly add parameters to all of the components in a project. Family parameters are specific to a family. So when you are creating a family, you create family parameters, and they can be used to control family geometry and other variables. The downside to family parameters is that they cannot be used in schedules or tags. But when you create a family parameter, you can actually create it as just a family parameter, or you can create it based on a shared parameter, which we'll get to in just a second. And so there is that ability to create parameters in the family editor and have them be scheduled and tagged. But if you just create it as a family parameter, then those parameters will not be able to be used in schedules or tags. But when you're creating a family, you will typically create several parameters in order to control the geometry and then to add the other variables that you'll need in the family. And so not every single one of those needs to be scheduled and tagged. And so family parameters are still extremely useful when you are developing families. Shared parameters are parameter definitions that can be used in multiple families or projects. And the reason is because they are stored in external text files. So then you can map projects or families to the text file and then be able to essentially pull from those parameter definitions. Shared parameters are very flexible in that they can be used in schedules and tags. And as we've seen with project parameters and family parameters, when you create them, they can be based on a shared parameter. And so that's how shared parameters are used. You either create it as a project parameter or a shared parameter and then just base it on one of the shared parameter definitions. And then when you're creating tags, you can add shared parameters to the labels, and therefore they can be those parameters can be tagged. So shared parameters are very flexible, and it's important to have a good shared parameter file with all the parameters that you will need in your families and projects. Lastly, we have global parameters. Global parameters are different from the other parameter types in that they are independent of element categories. You can create a global parameter and then use it to drive a dimension or other parameter values. Global parameters can also be used to report values. Global parameters can be extremely flexible and useful in your building models. For example, if you have duplex receptacles placed throughout a building model, each one of them has an elevation from level parameter. That parameter can be associated to a global parameter. And then if you update the global parameter, it will update all of the parameters that are associated to that global parameter. So let's say it changes sometime throughout the project, and instead of having to go back and select each one individually or use window selections or something of that sort, you can just update the global parameter. Or if you have dimensions that are controlling the placement of those duplex receptacles, you can then associate it to the global parameter to that dimension. And then that global parameter will drive those dimensions. So once again, if early on in the design stage where you're trying to figure out the placement, if you have them driven by dimensions, then you can update that global parameter, and it will update it everywhere where that global parameter is used. Just to summarize, in a sense, global parameters are almost like a way of making the project environment similar to the family editor, and global parameters can be very flexible in the design process. So just to summarize, there are project parameters, family parameters, shared parameters, and global parameters. In this video, we will cover creating parameters with the correct discipline and data type, and recognizing use cases for the available types. When creating parameters, it is critical that they are assigned to the correct discipline and data type. This will affect the functionality of the parameter as well as the available units. Before we jump into creating parameters, let's take a look at the project units. On the Manage ribbon, in the Settings panel, click Project Units. In the Project Units dialog, there is a discipline drop-down at the top. These are the disciplines that will be available when creating a parameter. Select Electrical. When you select a discipline, you can see the available data types. These will also be available when creating a parameter. Scroll down to Power and then click the button in the Format field. In the Format dialog, you can control the units for the data type. I'll leave power set to watts. You can then control the rounding and the unit symbol. Click OK to close each of the dialogs. Next, in the project browser, scroll down to Schedules Quantities and open the lighting fixture schedule. In this schedule, you can see several parameters that have been added, and some of them have units. In the Properties palette, click Edit next to Formatting. In the Fields list, select Voltage, and then click Field Format. This also opens the Format dialog, and you can choose whether or not to use project settings. If you want to change the units used, you can deselect Use Project Settings and then control the units. For this example, I'll click Cancel, and then I'll select Maximum Wattage and click Field Format again. When you deselect Use Project Settings, you can see that the Units drop-down is not available. That's because for maximum wattage, the only units that's available is watts. So the units that are available vary for the various data types. And as you use Revit more and more, you'll become more familiar with the units that are available. I'll click Cancel to close each of these dialogs, and then switch back to the floor plan view. On the Manage ribbon, in the Settings panel, click Project Parameters. To create a new project parameter, click Add. In the Parameter Properties dialog, you can go through the process of creating a new project parameter. As you can see, two of the options here are discipline and type of parameter. For this example, let's create a parameter called weight for the electrical equipment. In the discipline drop-down, you can see the same options that we saw in the project units. I'll select Common and then expand the type of parameter drop-down. These are the same data types that were available in the project units. For weight, you could select Number, but then we'd simply just have a number parameter for the weight. So we could also expand the discipline drop-down and select Structural, and then expand the type of parameter drop-down and select Weight. Now we will be able to use the weight units for this parameter. For the group parameter under, I will select General, and then in the categories list, I will select Electrical Equipment. And then I'll click OK to create the project parameter, and I'll click OK to close the Project Parameters dialog. When I go back to the project units and take a look at the structural data types, we can see that for the weight parameter, the units are pounds force. Whereas if we look at common, you can see that the number parameter is not there because it's simply a number, so there's no units assigned to the number parameter. I'll click Cancel and then I'll select the transformer. And then in the Properties palette, I'll scroll down to the General Parameters, and you can see the weight parameter that we added. Next, I'll select a lighting fixture and then click Edit Family in the contextual ribbon. When working in a family, you can also add parameters. On the Create ribbon in the Properties panel, click Family Types. In the Family Types dialog, you can see all of the parameters that have been added. To create a new parameter, click New Parameter. As you can see, creating family parameters is very similar to creating project parameters, with the two critical settings of the discipline and the type of parameter. I'll click Cancel to close this dialog, and we'll take a look at some of the existing parameters. I'll scroll up and select Apparent Load, and then click Edit Parameter. As you can see, this is a built-in parameter as indicated by the parameter type. And under Parameter Data, you can see the discipline and type of parameter. I'll click Cancel, and then when I scroll up, we'll take a look at the voltage parameter. And when I click Edit Parameter, you can see that this is a shared parameter, and the discipline is electrical, and the type of parameter is electrical potential. Be aware that there may be multiple shared parameters with the same name added to a family. When you have something like this, it's probably because somebody's grabbing families from multiple locations and they each have different shared parameters. And so you have to be aware of that. So just to summarize, when creating parameters, the discipline and data type are critical, especially for controlling the units that will be available for the parameters.